Good evening, everybody. This is Vishwajeet Chauhan. Today I will be presenting my PBL passion project. So let's begin. My passion project is the interconnectedness of math and science and the connection to the real world. So let's be. So first we need to understand these things. We know basic level of science and math, but we don't really know a deep amount. I will show you the deep amount explained in a very simple way. First let's break down math into group. First group is arithmetic, which is a type of math that that everybody learns. Even you have already learned arithmetic. It consists of addition, multiplication, division, and subtraction. You already know these operations. Then we have of course some of you have run more advanced arithmetic, which consists of brackets and fractions and other brackets. Now we have algebra. Algebra is whenever we use English letters or any letter of the alphabet to represent a number. It could be 0, it could be -2 or +2 or a fraction or a decimal or an irrational number like pi, etc. It could be infinite. Some of the most common used variables in algebra are x and y. So these are very important. This is also used for many other form of graphing for other stuff later on in this video. So the next step is geometry. Geometry is where math consists of shape. A point is a point that is drawn on a plane. What is a plane? That is whatever surface that you want to be. It could be round, it could be curved, it could be flat, or it could be a mixture of them. This is very important for later on in physics, which is a part of science. Anyway, let's move on. Continue. Okay, so so we have point. What is a point? It has no dimension. It is on a plane. Okay, we already know what is a plane is. Now, what if we take 2 points and draw and connect them, where you got a line segment. A line segment is whenever you connect 2 points, with with whatever. It is one dimensional. So 3D is whenever I can move like this, like that. 2D is whenever I can only move x, y axis. And I can 3D where I can move x, y and z axis. And 1D is when I can move on the x axis, which is this. So lines are one-dimensional thing that connect 2 points. Okay, they can be also straight or curved. What if we just continue this for infinity? What is the range of this is infinity. This is what we call a line. Unlike a line segment, it goes on forever or never ending. Okay, you might be thinking, okay, then how can a sphere can be where has a line there has a line because it can't have a line. After all, it with a sphere you can move anything and you will always go to the same place. So you can't have an infinitely long line, right? Well, this is where math come into a little more. Mathematician had it said, okay, a line that is intended for infinity. It can also just loop back on itself. Mathematicians said that due to the fact that physical geometry on a sphere was very useful for them, for example, especially to physicists and nearly a lot of people, because if geometry on a spherical level couldn't be achieved, how could they well know what is the size of Africa due to the curvature distortion whenever the distortion happened when we put Africa on the map, because in a group they are but on Earth the Earth is spherical. And if you look at a globe, Africa is much bigger than, let's say, Greenland. But we know Greenland is smaller than Africa, so we can put that in our head. Now let's go and do this on a map. There are many types of princesses, and this might not be a case for some of them, or not be a case of be a case for some and not be a case for others. But math always have one disadvantage to groups. So if we look at a map, we see that Greenland is bigger, is equal size to Africa. How could it be? On a globe, it should be smaller than Africa. Then you look at other places. Here it is smaller than Africa. So this map should be correct for. This might be too correct. But if you look closer, there's a problem. The problem is that Greenland doesn't have its shape right. This shouldn't be its shape. So this causes a problem. So now let's move on to shapes. Shapes are whenever you connect line segment or lines together to make a shape. It has a base it has an area. We calculate this area with multiple equations. So this is way. So you might be thinking, so these are very simple. No, they're sometimes be very difficult. For example, what is the value of pi? This might think this is the hardest question. But why is it important to know the value of pi? Well, pi is the circumference over the diameter. This is important if you want to, calculate the value of a circle. So let's say you order X size amount of pizza, but the pizza man said we don't have that size in currently, so why don't we give you this two smaller size pizza? So that should be more area than the larger area, and so it would be a benefit for you. For non-mathematicians, this is a great offer. However, smaller pizza should be more or equal to the larger pizza. But for a mathematician, they will actually calculate the area and find out, hold on, I'm still making one pizza. You need three small pizza to have roughly one large pizza. Or the pizza that you ordered. This is, and it can be also used for other stuff. At circus, basically come up everywhere in mass and a lot of things. Circles are basically everywhere. So, it is very important to find out what is the area of this circle. But you cannot do it normally. In, for example, a triangle, you can just calculate the area of a triangle with this measurement of the two sides, then divide that in half, and we get the area of the triangle. For the area square, it just is much more easier. Just take two sides or just one side and multiply by itself, because squares have all the same amount of same length of sides and have 90-degree corners at their ends. So all same size. So now let's It took thousands of years for mathematicians to figure out this ratio. Then came Isaac Newton, who found a very clever way to do this very fast. Of course, I cannot share this method to you because it's going to take too much time, and the video need to finish and not be at a rant of a lot of hours. So okay, let's move on. Then we have a little more advanced algebra. Oh, then and algebra again. Well, see, you might thought, okay, algebra is just about variables. There's also more to it. It's about how to change this variable, and by not losing the product, this can make calculation much more easier and easier. And you need that because and we are going to run further down this math journey. We are going to find much more difficult problems that you need to solve. This is the core part of algebra. The point of running all these variables and this stuff is to manipulate equations to make them easier to figure out. Anyway, now let's move on to trigonometry. You might be thinking, what is trigonometry? Well, as the name it suggests, it's about triangles. In trigonometry, we have many functions like, for example, sine, cosine, and tan, which are all from triangles. You can make all these from triangles. This is where you have to draw sine waves and graphs. This is where you need most of your graph later down the math journey used up. So we have to draw sine waves and do some calculation to find the value of these sine waves and their angles. You might be thinking, how does the sine wave have an angle? Aren't they just the curved line connected to one another flipped? Well, you will be somewhat wrong because as the name implies, trigonometry, the triangle involved. So the triangle. So might be thinking, okay, so triangles have angles. So what is the important that? It has a lot of angles. For example, we can make a sine wave just using triangles. And the angle of this is very important. If we get the wrong angle, well, stuff goes bad, very bad, and you'll fail. And this is important for things like in science, such as the frequency of light. The frequency is the separation between two sine waves. So So this is important, and if we can derive assignment from a triangle, we can derive a triangle from a sine wave. This is important, of course. Now let's move on to topology. You might be thinking, what is topology? Topology is saying it's kind of different type of geometry. In here we have in here we take three-dimensional stuff like a ribbon or ring, and we have to manipulate them to whatever to create a certain thing. For example, you can make a donut of a teacup. Vice versa, you can make a teacup out of a donut. Topology says that it's possible and they're the same because we can make one after the other. It makes me manipulating, stretching, and manipulating, changing what direction it's facing, etc. But not cutting. It is not allowed to cut anything or glue stuff, which is a thing that you should know, because some people would just cut it and I just done it or grew it. Glue, I mean pick. I mean that they are connected to each other by just gluing. This is of course not possible in topology. Okay, so what else we have? Okay, first of all we have number theory, which is about numbers. We already run them. We already have run a few of them. But we have the natural numbers. The numbers that we all know. These are 1, 2, 3, 4, 5, 6, etc. to infinity. Now we have if we add 0 to the natural number, what will we get? 4 numbers. This basically add a 0, and that's all. Okay, now let's move on to negative numbers. Negative numbers by their name are negative. Literally. Then they have a minus sign in front of them showing that they are negative. This is very important to run, because instead of thinking, we can, so we need to add minus 225 from 426. And you might be thinking, what is this minus sign in front of this number? Might be a mistake. Then you get a fair because you didn't realize the minus sign meant the negative sign. So this is a handy thing to take care of. Now we have rations. Rational numbers. 1, 2, 3, 4, 5, 6, 7, and negative 2, 0, and fraction like 1 half, 1 4, 1 6, etc. You get it. Okay, now we move on to irrational number. I already said them before. Pi is one example. It just go on to infinity forever. Fun fact: there are more irrational numbers than whole. Then whole numbers combined. And by thinking, how is that possible? Shouldn't there should be more irrational numbers than shouldn't there be less irrational number than rational number? Then you will assume wrong. Or you might even think, hold on, both of them are infinite. So shouldn't they be equal to each other? Well, then you're also wrong. Am I thinking how? Well, it's quite simple. I won't say the method, but it's quite simple. You just take then this number. So basically, on the left side you have the list of when natural numbers or whole numbers. Then on the right side we have all the irrational numbers. This is of course impossible, but you can make a smaller part of. You add irrational numbers are infinitely long. You can basically add whatever you want. For example, you can add pi at first, then 1/3 or etc. So you get it by this point. So you just take the first number of the irrational number and add 1 to it. If it's 9, then subtract that by 1. Then move on to the second number of the second irrational number of the second line on the second place. Now do that again. Add 1. If it's a 9, round back to 0. Go back to 8. And now you have a string of numbers that are different from every other number by at least 1 digit. So now you have one irrational number that shouldn't be on this list at all. After all, it shouldn't be on this list, but are still considered an irrational number. This shows that natural numbers are less than irrational numbers. So now let's continue because well, I need to talk about the science part now. Science but first we have to do a little bit of math again. So first of all we have math, and there are different types of math that we already saw and learned a few of them. Then there's a lot of them. I cannot say all of them in this video because it's going to take too long. So now let's just move on to science. In science we have, let's break this down into multiple parts. First part is physics, then chemistry, then biology. Oh yeah, I forgot one. I'm going to not share this one with you. I'm just going to share this one later. First of all, let's start with physics. In physics, we already learned a few of them. For example, gravity. We all know that for things fall down at this rate of things. You might not learn this rate of things, but it tells us what is the attraction force of two objects. And this goes out to infinity. So you could be a tiny that passes by thousands of millions and millions and millions and millions of light years apart. Light years apart is attracting you here on Earth, and it's very far away, as I said. Right? You might be thinking, what is I writing? Right here, whenever a light takes a year to go from this place to this place. So that is what we call a light year. That is the distance, because the numbers are getting so big that it becomes time travel, but we are going to talk about that later. So let's continue. As we know that let's say if gravity attracts forces at this rate of numbers. So that rate I'm not going to imagine because this is going to take too long. So gravity moves by this rate of a number down. Then Einstein came along and said, hey, this is not actually the truth. Gravity does not pull everything in not a force. Then everybody else like, what? Huh? Everybody else was confused, but Einstein shown that gravity just bends space-time so you can just go down. So instead of normal things like say normal thing where the gravity just go down, it just curves space-time around it. So you have already accelerated. So whenever we move up, we just we move our velocity changes to zero. Then due to the sheer curveness of the space around, space in and around us, we go down. This is very. Then this was a shock. One of the shockers of Einstein. There will be more bombs dropped by Einstein later in this video. Okay, so now how do we move? You might be thinking, oh, this is very simple. I just move and take like this to move. But there's a little more to it. First of all, that friction is whenever when you whenever two things rubbing against each other causes friction. This is obvious and very important because without it, if I just stand here, I will just slip down. But thankfully, this is here, so I don't slide down. But if this wasn't here, I would just slide down on and on till I met the river. It would be bad. Like I would get very hot because I fell. That's acid there. So, but with friction, the gravity is made sure that I don't fall. The gravity and where the friction helps to say, oh, okay, you're not going to fall down. But in here where there's a slope down, and I'm sitting here, gravity just helps me slide down, which is not good for me. As I would get hurt again. So, but friction says no. There's atoms and molecules here, and so I'm going to reduce it. And with my standard being with this shape, it had more surface everywhere in the ground, which caused it to be more reduced. Which is good for me because I don't want to try that and get hurt. Okay, friction we got it. But there are multiple types. This is one of them. The other one is water resistance, which is a type of friction. It's basically whenever the water molecules hit something and slow that thing down or speed it up if the water molecules are going at a higher speed. This is bad for fish, submarines, boats, or anything that will want to float or swim in water or on water. So how that's where fish overcome it. It has a streamlined body, which is in biology. So it basically makes it so that the water molecules smoothly go around it. So the fish can be agile and still swim in water. As you can see. Currently there are no fish in the water, or I cannot see the fish in the water. So So, this is second type of resistance and called air resistance. Air resistance is much less powerful than water resistance, also known as what? Water resistance. Water resistance has more powerful because it has so much more molecules than air, because air is actually a lot of nothing. So you can condense your a room down to 0.001% of the stuff, and that's the amount of stuff that is in the average amount of molecules in that room. And the rest of it is nothing, which is quite boring if you think. But it is good because now we can move freely and don't feel like we are in molasses or honey, which would make it very difficult to move, obviously. So, and they shut the birds because when that's resistant, they can fly easy and have different more suitable shapes of their bodies, then makes it easier for them fly. So now let's move on to energy. Energy is an imaginary term, you might think, but what isn't energy a real thing? Well, not. It is a tool that physicians use to physicians and other people in working in science use, because it's a good tool to use for many problems. But energy doesn't actually exist. But still, it's a good tool to have, so I'm going to share it with you. There are multiple types of energy. There's kinetic and potential energy. Potential energy is energy that is stored. For example, my mother is holding up the phone that is recording this video on. It is at this height. So, it has potential energy at kinetic energy whenever it's moving, and it is currently not moving. So what if suddenly my mother dropped the phone? Oh no! Now the potential energy has been converted to connected energy. You might think that's not too bad. What harm could it be? Well, there's a lot of harm in it. First of all, if it has enough potential energy and or the rest of them better, any resistance or any forces on the things slow down, and to calculate all the forces that slow down or accelerate the speed, which is the numbers adding and hello everybody. I had to take the break between this video for water and the fact that there was a lot of mosquitoes biting me everywhere. So, and I don't have enough time, so I'm just going to do my level, which is grade 6. Which is basically done. Light is opaque, transparent, and translucent. Opaque is whenever light hits the object and where nothing happens, and the light is reflected off the object into our eyes and we can see. Translucent object is whenever partially we can see the light source. So we cannot clearly see it, but we can see it see it. Transparent is like glass. We can completely see the object with no difficulties. Now, now, now our eyes see it inverted, but our brain processes that and flips the image, which is good because unless we would see everything upside down, which would not be good and very hard to move. So, so you might now let's continue with it. So let's say I now okay. Thank you for that word for topping that. Anyway, I will continue now. Something such as mirrors reflect the light 100%, so we can see the light source, you, me, etc. But opaque object doesn't do that. Well, not really. Most opaque objects doesn't do like me or the t-shirt. Whenever the light hits the t-shirt, it absorbs all the other forms of light and leaves only the color and the two colors that it made out of and two or more and leave some color that is reflected into the camera and into your eye that you can see. Of course, this is a camera, but it's a lengthier process, but you get the point. While mirrors has a special thing. They reflect every light, every type of light, which is good because if we, let's say, good. Let's say if we want to see ourselves, we can do that. Or when we make a periscope, you might be thinking, what is a periscope? Periscope is whenever basically a tube with two ends which are twisted at a right degree angle, and in that tube are two mirrors. One is mirror A, which is degree at 45 degrees like this. The other one is mirror B, which is again at a 45 degree angle. So light comes through, bounces off this mirror, and into our eye. But so here we can see higher than we should, which is good for stuff like submarines or train sets where you need to see stuff that you shouldn't be able to see or and without being at the reach of danger. So open your camera. Light comes through here. And the box has a pin here or a hole. The light goes to here and makes an opposite image of that. Our eye corrected, then our brain wrongs it and makes it well wrong again. So we see not see process or see it as upside down. Yes, it is. Then for that brain. And that could be a source of light and object by a sort of light. Now let's move on. Okay, now write it down. Thermodynamics relates basically heat and talk. Heat is whenever, let's say, a thing has heat and it whenever the molecule and atom move around in an object and that kinetic energy is called heat. It is, and our brain, our neurons fear our receptor heat, that special type of receptor in our body for heat, fear that send the information to the neuron, and the neuron send it to our brain, which is made of many neurons. We process that and we feel that as a sensation that we call hot or hot, heat, hot, etc. You get the point. The amount of bitterness makes the temperature measurement system. First, we are Kelvin, which is a scientific method that everybody should use. When if you want to be scientific or doing the research. But if you are speaking in layman's or common terms, just use Celsius, which is good enough, and basically everybody uses it except for a few countries who decided, no, we are not going to use this widely available great system, which is going to make this very poor, bad system. Where they are going to keep on to this very poor, bad system. See, the Celsius was not the first thing that we did. The Celsius was the second measurement thing that we did. The first one was Fahrenheit. The ridiculous thing for freezing thing. Of course, everybody doesn't feel the same amount of heat or same amount of heat at the same amount of intensity. Some people, like for example, British people, let's say a pretty cold for us would be burning and would be very hard but for Nepali countries it would be astronomically hot. Vice versa, for them a good temperature would be very good for us, etc. So you get the point. Okay. Okay, as I continue speaking, so the church system was invented in the French Revolution, and people want a new thing and rid of the old system and everything, like the monarchy. So they decided, as I was saying, socialism made using the rational thinking where, okay, water freezes below zero, and if it at zero, water is just still and we don't it's still, and everything above it, and everything above zero makes it boil. So 100 is boiling point and the 0 is freezing point. Simple. But you might be thinking, oh, so really that was simple. Where you will be wrong. Although many people credit the French for this invention, it was actually the Swedes who designed this. The Swedes made this system by a physicist of who was Swedish. But it fit nicely with the French system, the metric system. So in the original Swedish design, it was where 100 is when it freezes and 0 is when it boils. You might be thinking, well, that makes no sense. Might be thinking that, but at the time it actually made quite a lot of sense, and I'm going to prove it. In Sweden, it's very cold, and really goes to negative degree, and really becomes very hot, to say the least. So this is very so at that time, no one really, if you wanted to have. Sure, there would be a very, very slim chance that you have to use negative Celsius. So, negative X Celsius. But you are probably going to use more positive Y X Celsius. So like you were more going, you have going to experience more positive things, more, well, colder thing than hotter thing. So if we make the hotter thing at zero and the colder thing at to infinity positive, and the even more hotter thing negative infinity negative to infinity. Well, you have a good system, but for the rest of the but then around the country adopted and flipped the measurement because what it more. Thank you for that word for setting up. Anyway, as I was saying, most of the world didn't were experience very cold climate and where it really got hotter, so there would be where water that wouldn't freeze outdoors. So most people just flip the system 0 if it were frozen 100 and beyond for boiling. Kelvin was discovered moderator. It was the last of them. Well, one other, right? There are thousands. There are a lot of measurement system, but these are the three main ones. It was discovered later. It is when people began to, where science really took a turn. A lot of them. They discovered molecules and atoms, and more precise model molecular atoms in the head and could explain more stuff about molecular atoms. So they made the Kelvin care. Basically, it was designed made by the care. Made by Thomas Kelvin, who made the Kelvin care. 0 for the norm. The molecules are frozen, then don't move at all. And the more and more you get, the more faster they move. It is good if you want to be scientific about things and talk in a scientific way. But if it is saying with genuine information, this is a very poor way to use this. A very poor way. So, now, measurement done, right done, heat done. Heat right done, gravity done, and yeah. Also then magnetism with whenever magnet which we will be running out in the high grade because we don't have time right now to explain all of this. Okay. Chemistry we don't have in shit grade. Okay, now chemistry is gone. Then we have biology. Biology is very easy. Then again, as I mentioned, streamlined body. They apply to birds and well, fish because they need have less resistance. But fins to move. One tail fin and some smaller fin to start and help with the bigger fin, the tail fin at the back. Imagine it like starting a car, starting a petrol car where if I need to start a smaller engine to power the bigger engine so the bigger engine can do its work. It's kind of like that. That is just fins and helping other fins so the fish can move inside of the car. Okay, so now let's move on to birds. Can you point the camera the other way? As you can see, at our place we have a lot of birds. A lot of birds. Now let's examine them. Using these cameras, as we can see, they have wings. Can you point it in the correct way? Yeah, thanks. zoom, zoom, zoom. Yeah, this is good enough. And we can see they have wings and a beak and necks and rings. Okay, so let's talk about the wing because they are the main part of the body. They are the most important part. Without them, they couldn't fly, and for some, they couldn't swim or just swim. So basically, a bird uses its wing and it flaps around like this. And it uses very powerful method to help it breathe, helps it lungs because it's going to take a lot of energy and muscle power to do this. And they have a lot of muscles here on the arm that help the arm to flap a lot, so they can generate lift. Basically, air molecules first they move the down through. They basically put them down, put the air molecule down, and as Newton said, every reaction has a equal and opposite reaction. This causes the bird to go up. This is the same by rockets, helicopter, and airplane. Not airplane, airplanes. Yeah, airplanes also work very similar way. So basically, every flying thing needs to do this. Any moving thing, basically everything needs it to move. So now, so they put the air molecule very fast, and this is called the downstroke. Because the wings are moving down. Then we have the upstroke, where the thank you for that bird for setting up. Can you please shut up? Okay, anyway, the wings moves up in a way that it doesn't push that many air molecules up, then it went down. So now it is up again, so it can go down and up and down and up, and now the bird is flying. Great. Birds down. Now we have insects. Insects have an exoskeleton. You might be thinking, what is that? Basically, the skeleton, all of their bones are on the outside. And so let's examine a snare. It has no exoskeleton or an. Didn't you say insects have exoskeleton? Well, yeah, but most of them do, but some of them like snares, slugs, and other stuff doesn't really have any skeleton. So they have a soft skeleton and a shell. The shell is where they live. So whenever, let's say, a bird tries to attack them with its beak and try to eat it for some, because what else the bird going to eat? Something else? No, I don't know. Also, the snare can go back to its hole and be protected. Go back into the shell and be protected. And whenever the bird decided, and they're going to find some other food, or found another food, and they're going to go back, or basically any other reason where the bird moves away from the snare, and the snare is safe now. It can go back outside, and it can continue moving. But you have seen nothing. If you haven't seen nothing, they don't have legs or fins or wings. So you might be thinking, how do they move? The answer to that is very simple. They have one muscular foot, which basically is a large amount of their body, which is the underside of the snare. And okay, as I will continue, It's a mercury food which also secretes a slimy mucus substance, which is called mucus. This reduces friction and the foot can grab onto the stick to the material via the mucus, letting it climb onto whatever surface. It also the mucus also prevents any sharp end from happening. So let's say if you want to cut a snail for some reason, maybe I don't know, you are friends, don't cut it via the microphone. Cut it on the head, obviously. Okay. Also, you might not get the French joke, but basically in France, they eat snail for some reason. Anyway, as I was saying, they also they basically prevent any injury from happening because where any sharp object that the mucusy mercury foot crawls on will be neutralized, so it is very safe. Now you can even move it, so it won't cut as much, which is good. Obviously. Okay, now snares and slugs are done. Now let's move on to all the other ones. But we are just going to focus on the stuff in my book. And it says that the next one is cockroach. The cockroach has 6 legs and it moves 3 of them at one time. Step 1, it moves these 3 legs. Step 2, it moves these 3 legs, and again move these 3 legs and anchor the rest. Move. Okay. Step 1, leg 2, 3 move, and leg 4, 5, 6 don't move. While in step 2, leg 1, 2, 3 don't move, and leg 4, 5, 6 move. And also the cockroach has wings, because why not? And it needs a creative, annoying face. Now that is a silly question, why did they create? Anyway, the cockroach has wings insects are very light and where cockroaches are. And it move very fast. The cockroach can fly. It is the worst thing about them. So they can fly. Now what? So cockroach is done. And I'm not going to say any further. So biology, mathematics. Now biology, physics, chemistry, not here. So yeah. Now for the secret subject. The secret subject is math. So in mathematics. So you might be thinking, what? Alright. Math is a type of science? Well, yes. The scientists have considered math as a type of science. Even though it can be classified as a human invention or a natural discovery or whatever, right? It is very complex to say the least. Anyway, now let's move on to the river. If you want to do anything with mathematics, physics, anything about cell reproduction, mathematics and physics, or the rate amount of about cell reproduces, mathematics and physics. Mathematics and Biology, which is the chemistry advanced form. Anything do you want to learn about chemistry? Like, I don't know how many how many at how many how many atoms are there in this amount of things. If it filled with pure oxygen and it weighs 23 grams, how many molecules, how many atoms will be there? Okay. Again, mathematics has its covered, and this is a part of chemistry. Biology was already done, and physics already done. So, the end. This is the end. If you want things that related to science, well, that's the end. Seriously, you can just see anything, and it has a scientific and mathematical reason for it. The end. Have a wonderful, great day. And the end. Bye.